Hello everyone. Today we will study about a semiconductor diode. So there are so many types of semiconductor diode, but we are specifically studying in this session about a PN junction diode. So what do you mean by a diode? A diode is a two-terminal device. So what do you mean by a PN junction diode? It's a PN junction with two metallic leads on both sides. So that is it when a PN junction is taken and it is having two metallic leads. This is what is a PN junction diode. And the symbol of a PN junction diode is like this. This is the symbol of a PN junction diode. And in its makeup it look like this. It will be a black cylindrical portion with a silver ring. One of the diode is like this with a silver ring like this, and the silver ring side is the negative side and the other side is the P side. The circuit symbol of a PN junction diode is this, and this is the P side and this is the N side. So a PN junction diode consists of a PN junction. It's a two-terminal device with two metallic leads so that we can fit it to a battery or any other circuit. I hope that you have understood this and the circuit symbol also. Next, we will study about a process called biasing. So biasing is the process of applying a potential difference to a PN junction diode. So there are two types of biasing. The two types of biasing, the first biasing is called forward biasing and the second biasing is called reverse biasing. So how will you do forward biasing and reverse biasing? So what is biasing? Biasing is the act of applying a cell or a battery to a PN junction diode. So forward biasing of a diode means if this is a PN junction diode and we are connecting it to a battery, how I can connect it? We can connect it like this, right? So the P region is connected to the P terminal or the positive terminal of the battery, and the N region is connected to the negative terminal of the battery. This type of biasing is called a forward biasing. So how is it a reverse biasing? It is like this. Listen. If we are connecting it like this, so what happens here? The P side of the diode is connected to the negative terminal of the battery and the N side is connected to the positive terminal of the battery. So this is what is meant by reverse biasing. So now we have to study what happens in forward biasing when a diode is in both cases we have applied a battery. But when we apply a battery in this way, what is happening inside a PN junction or a PN junction bar? Or when it is reverse biased, what is happening? These are the things that we need to study. Next, we will study about a PN junction diode in its forward biased. So you remember what I have told you. A PN junction, I'll draw a PN junction. So this is a PN junction and we know that a potential barrier is created here and there is a P acceptor core here, then N acceptor cores here with the electrons here, P acceptor cores with the holes here, and there is a space charge region in between where there are only acceptor cores and donor cores and there are no mobile charge carriers. So in this case we are going to fit this PN junction diode to a battery. How we can apply forward biasing? This is the P region and this is the N region. So P is connected to the positive terminal and N is connected to the negative terminal. This is the way of applying a PN junction to a cell or a battery in forward biasing. So what will happen in a forward biasing? We know that there is a potential difference created here and there is a virtual battery over here. And this virtual battery is like this, right? This is not a battery fitted, but this one is a virtual battery here. So what happens in this case is the electrons here, and we are applying a battery over here, an external battery. What happens here is that this is the positive side, right? And this positive side of this battery will repel these positive holes. Repulsion means they are giving some energy to these positive holes. And the negative terminal, as it is negative and there are negative electrons, there is a chance of repulsion over here. So what happens is that the repulsion of this positive side towards the hole and the repulsion of the negative towards this from the electrons move from this region to this region due to this repulsion. What happens is that they try to cross this junction. There is a potential barrier created here. Of course, when we look at these two electric fields, we can understand that this electric field provided by our external battery is in this direction and the virtual battery or the potential created here is in this direction. So both are negating each other, isn't it? So if there is a potential difference here which is trying to avoid this crossing, our battery is applying a work because both are in the opposite direction. So our battery is applying a work to negate what is happening in this region. So what happens is that if our battery is more powerful or the cell is more powerful or it can provide more potential difference than the potential barrier existing across this junction, what happens is that the electrons, the majority carriers from this side can cross the potential barrier and the holes also can cross this potential barrier to both sides so that a conduction is produced. Electrons is moving to this side and the holes is moving to this side and there is a chance of conduction. So what is it? A PN junction diode in a forward biasing, it can conduct current. It can conduct current, that is it. So what is it? The positive terminal of the battery is repelling the holes and the negative terminal of the battery is repelling the electrons so that they can cross the junction so that the PN junction diode in its forward biasing can start conduction. That is it. I hope that you have understood it. So now let us focus on the potential barrier diagram of this. So if this battery was not applied, what happens? If this battery was not applied, let us draw the potential barrier diagram here. So if I draw a potential barrier graph here, how will it look like? There is a potential over here and I have drawn it in terms of a virtual battery. So this is the P side and this is the negative side. So when I draw a potential barrier graph, it should look like this. I am drawing this in this region. So this is the distance versus potential graph. So here is as it is negative, the potential is less. And here it is positive, the potential is more. So this is the potential barrier graph of the potential barrier. It is potential over distance actually. So when somebody asks you to draw a potential barrier graph, how will you draw? It will be just like this. Just like this. The negative is this side and the positive is this side and this is the potential barrier existing. Potential barrier. Potential graph. So while we are trying to incorporate a battery in its forward bias, the diode is in the forward biased condition. So P to P and N to N, or P to the higher potential and N to the lower potential. So the potential barrier is here. So what happens? If some value of potential barrier is here and I am going to apply a battery and I increase the strength of the battery or the potential of the battery, what happens to the potential barrier? These electrons move to this side and the holes move to this side. So what happens to the depletion layer here? In the first case, the depletion layer was of this much thickness, right? So when the electrons and holes try to cross this junction, what happens to the potential barrier? The potential barrier height decreases. So in this case, the potential barrier height decreases. So this is the first case when I increase the strength of the battery. So potential barrier height decreases because it can come more close to the junction and cross the junction. When we again increase the battery that we are applying, the power of the battery that we are increasing, so what happens is that the potential barrier again decreases because more and more electrons can cross this junction or the depletion region. So the graph will be like this. The potential barrier height get reduced when we apply more and more strong battery. And what happens to the width of the depletion layer? It decreases because this much was the depletion layer. When more and more electrons or holes can reach the region and cross it, what happens? That the width of the depletion layer decreases. These are the two questions that can be asked as 1 mark or a multiple choice or anything like that. What happens to the potential barrier when a diode is forward biased? When a diode is forward biased, the height of the potential barrier reduces. Then another question is, what happens to the width of the depletion layer when a diode is forward biased? That when a diode is forward biased, the width of the depletion layer decreases. These are the two important points that we have to understand. I hope that you understood the PN junction diode in its forward biasing. So let us come with the PN junction in the reverse biasing in the next class.